Hello and welcome to your Chapter 6, Lesson 2, video number 1. Today we're going to apply properties of rational exponents. So obviously your objective is that you're going to simplify expressions involving rational exponents. So properties of rational exponents are as follows. We're going to let a and b be real numbers and let m and n be rational numbers. The following properties have the same names as those in lesson 5.1, but now apply to rational exponents. Sometimes students are a little hesitant to apply the properties of exponents when the exponents are rational. So when you have a to the m times a to the n, you still add m plus n. You still add those two exponents. So if I have 4 to the 1/2 times 4 to the 3/2, that's going to equal 4 to the 1/2 plus 3/2. 1/2 plus 3/2 is 2, so then we have 4 squared, which is 16. A to the m to the nth power to a power there, is going to equal a to the m times n. So let's look at the little example here. We have 2 to the 5/2 squared. So we're going to multiply those exponents together. So we multiply the 5/2 times 2. And 5/2 times 2 is 5. So we have 2 to the 5th, which is 32. AB to the nth power. That means we're going to raise a to the nth power and b to the nth power. So when we have 16 times 4 all to the 1/2 power, that's equal to 16 to the 1/2 power times 4 to the 1/2 power. 16 to the 1/2 power is the same thing as square root of 16, and so that's 4. 4 to the 1/2 power, that's the same thing as square root of 4, and so that's 2. 4 times 2 is 8. A to the negative m is 1 over a to the m as long as a is not equal to 0. So 25 to the negative 1/2 is going to equal 1 over 25 to the 1/2. And then again, an exponent of 1/2 is the same thing as taking the square root. Square root of 25 is 5, so that equals 1/5. A to the m minus n, or excuse me, a to the m over a to the n is equal a to the m minus n, as long as a is not equal to 0. So if I have 3 to the 5/2 over 3 to the 1/2, I just subtract those exponents. I have 3 to the 5/2 minus 1/2. 5/2 minus 1/2 is 4/2, which is 2. And so I have 3 squared equals 9. A divided by b all to the nth power is equal to a to the m over b to the m as long as b is not equal to 0. So if I have 27/8 to the 1/3 power, that is equal to 27 to the 1/3 power over 8 to the 1/3 power. Okay, remember, raising something to the 1/3 power is the same thing as taking the cube root. So we have the cube root of 27, which is 3, over the cube root of 8, which is 2. So it's equal to 3/2. All right, we're going to use those properties of exponents to simplify the expressions that we're given. So we have 7 to the 1/4 times 7 to the 1/2. So we're going to add our exponents. So we have 7 raised to the power of the sum 1/4 plus 1/2. 1/4 plus 1/2, that's the same thing as 1/4 plus 2/4, so that's 3/4. And so our answer is 7 to the 3/4 power. 6 to the 1/2 times 4 to the 1/3, all raised to the second power. And so we can raise each of the factors to the second power, and so we're going to have 6 to the 1/2 to the second power times 4 to the 1/3 to the second power. Now we have powers to a power, so we're going to multiply our exponents. So we have 6 to the 1/2 times 2 times 4 to the power of 1/3 times 2. 1/2 times 2 is 1. 1/3 times 2 is 2/3, so we have 6 to the 1st times 4 to the 2/3. 6 to the 1st is just 6, and there's really no way to simplify that any further. 4 to the 5th times 3 to the 5th, all to the negative 1/5 power. What we can do there is we can go ahead, since both bases are raised to the 5th power, we can go ahead and multiply first. So we'll have 4 times 3 to the 5th power, all raised to the negative 1/5. 4 times 3 is 12, so we've got 12 to the 5th to the negative 1/5. So we can do 12 to the power of 5 times negative 1/5. So that's 12 to the negative 1 because 5 times negative 1/5 is negative 1. And so that's just the reciprocal of 12. So the answer is 1/12. All right, we've got 5 divided by 5 to the 1/3. Now remember, 5 is also 5 to the first power. And so from here we can subtract our exponents. So we have 5 to the power of 1 minus 1/3. So that's 5 to the 2/3, and that's simplified. We have 42 to the 1/3 divided by 6 to the 1/3, all squared. Since both of our powers are raised to the same exponent, we can divide first and then raise to the 1/3 power. So we have 42 over 6 to the 1/3 power, all squared. 42 divided by 6 is 7, so we have 7 to the 1/3 power squared. And so we're going to multiply our exponents. So we have 7 to the power of 1/3 times 2, so that's 7 to the 2/3 power. All right, we're going to look at an example here in biology. A mammal's surface area, S, in square centimeters can be approximated by the model S equals K times M to the 2/3, where M is the mass in grams of the mammal and K is a constant. The values of K for some mammals are shown below. Approximate the surface area of a rabbit that has a mass of 3.4 kilograms. And so the rabbit has a constant there of 9.75. So we're going to write our model. In general, it's S equals K times M to the 2/3. We're going to substitute 9.75 for K and 3.4 times 10 to the 3rd for M. And so we get 9.75 times 3.4 times 10 to the 3rd raised to the 2/3 power. All right, we've got power of a product property. And so we're going to raise everything that's inside the parentheses to the 2/3 power. So the 9.75 doesn't get raised to it because it was outside the parentheses. And then we have times 3.4 to the 2/3 power, and then times 10 to the 3rd power to the 2/3 power. All right, we're going to do the power of a product property again. Actually, this is power of a power. We're going to multiply those two exponents together. So we have 9.75 times 2.26 times 10 squared. Because 3 times 2/3 is 2, that's why it's 10 squared. And so now we're going to simplify, and it's approximately 2,200. The rabbit surface area is about 2,200 square centimeters. Okay, some properties of radicals. There's the product property of radicals and the quotient property of radicals, and they come from these properties of exponents for rational exponents. The nth root of a times b is equal to the nth root of a times the nth root of b. And the nth root of a over b is equal to the nth root of a divided by the nth root of b, where b is not equal to 0, and where all of these values represent real numbers. We're going to use the properties of radicals to simplify the expression. We've got the cube root of 12 times the cube root of 18. So we're going to use the product property to do the cube root of 12 times 8. 12 times 8 is equal to 216, which is a perfect cube. 216 is equal to 6 cubed. So the cube root of 6 cubed is just 6. We've got the fourth root of 80 divided by the fourth root of 5. Well, since we're taking the same type of root of the numerator and denominator, let's just use the quotient property and do the fourth root of 80 divided by 5. So that's the fourth root of 16. 16 is 2 to the 4th power, so the fourth root of 16 is just 2. Okay, simplest form of a radical. A radical with index n is in simplest form if the radicand has no perfect nth powers as factors and any denominator has been rationalized. So we're going to write the expression in simplest form. And then after we finish this example, we're going to end video 1, and then we'll come back for video 2. All right, we've got the cube root of 135. So we want to factor out any perfect cube that we have. 135 equals 27 times 5, and 27 is a perfect cube. It's 3 cubed. We use the product property then, and we've got the cube root of 27 times the cube root of 5. Cube root of 27 is 3, so we have 3 times the cube root of 5. right, let's look at B. We've got the 5th root of 7 divided by the 5th root of 8. Well, if we did the 5th root of 7/8, that's not going to really help us here because that's not going to reduce. What we need is what is inside the 5th root sign in the denominator to be a perfect 5th power. That way we can get rid of the radical in the denominator. All right, so we've got 8. 16 is 2 to the 4th power. 32 is 2 to the 5th power. So if we multiply 8 by 4, we'll have 5th root of 32 in the denominator, and we'll be able to simplify that to 2. But if we're going to multiply the denominator by 5th root of 4, we have to multiply the numerator by the same thing. So we're going to multiply on top and bottom by 5th root of 4. So on top, that's going to give us the 5th root of 28. On the bottom, that's going to give us the 5th root of 32. 32 is equal to 2 to the 5th, and so the 5th root of 32 is just 2. So we have the 5th root of 28 divided by 2, which is in simplest form. 28 is equal to 4 times 7, and 4 is 2 squared, 7 is prime, so there's no perfect fifth powers as factors of 28 that we can bring out. And we don't have a radical in the denominator, so we are in simplest form. All right, we're going to come back and talk about like radicals and look at our last few examples. I'll see you in video 2.